Hello, welcome back to Statistics and Mathematics YouTube channel. Today we are going to learn what you call normal approximation to binomial distribution. So in our previous video we learned quite a lot on introduction to normal distribution, standard normal distribution, central limit theorem, and applications of standard normal distributions. So if you haven't watched that video, please kindly go back and then take your time and then watch those videos because it will be very helpful. So let's start. For normal approximation to binomial, it means that we are going to use continuous probability distribution to approximate discrete probability distribution. So for example, we are trying to say that when our n is large, and if you want to use the binomial distribution to make the calculation, things become very difficult. So you have to switch using the normal distribution to approximate the binomial distribution. It said a normal distribution often used to solve problems that involve binomial distribution, since when n is large, the calculations are too difficult to do by hand using the binomial distribution, as I've already discussed. So the next property is to check. When the question is given to you, you have to check if our mean for the binomial distribution, right? If our mean for the binomial distribution, that's NP, is greater than 5, or if our NQ is greater than 5. If these two conditions are satisfied, then we can boldly say that we can use normal distribution to approximate binomial. And then we have what we say, like when you want to use the normal approximation to when you want to use the normal approximation to approximate what the binomial distribution, you have what we call a correction for continuity. It's a correction employed when the continuous distribution is used to approximate a discrete distribution. So always when you use the continuous distribution to approximate discrete distribution, we use what we call a correction for continuity. So let's go to the next slide for me to summarize the normal approximation to binomial distribution for you. So here you have the binomial, and then we have what we call the normal. So in case when you are asked to find the probability that our x is equal to a, right, in normal distribution, this is what you are going to do. We are going to find the probability that our x lies between a minus -5 and then a plus -5. So you are just going to subtract -5 from a to the left side and then add -5 to a to the right side, right? And then the second one said probability that our x is greater than or equal to a. So here, if you have been given a binomial distribution, you have been asked to find probability that our x is greater than or equal to a. This is how you do it, right? This is how you do it. You find probability that our x is greater than a by subtracting 5 from it, right? By subtracting 5 from it. So let's go to the next one. So the third one is you should find probability that our x is greater than a, right? Note the second one is different from the third one, right? So probability that our x is greater than a. For normal distribution, when you come to the continuity correction factor, when you come here to probability that our x is greater than a plus 0.5. So when it is greater than, without the equal to, you are just going to add 0.5 to it. But when it is greater than with the equal to, you are just subtracting 0.5 from it. And therefore, you should find the probability that our x is less than or equal to a. Here, to the probability that our x is less than a plus 0.5, right? And then probability that our x is less than a, it will be equal to probability that our x is less than a minus 5, right? And then the same thing, if you are asked to find the mean, you are still going to use our n times p, that is number of observation times probability of success, and our variance will be square root of our number of observation times probability of success times probability of failures. And then we are going to check our criteria first before we will solve the question. So here we are going to check if the number of observation times probability of success is greater or equal to 5, or our n times scale is also greater than what? Greater or equal to what? 5. Right? So this is how things are done here. So let's go to work example for us to really appreciate what we have already discussed. So one, we are saying that a magazine reported that 6% of American drivers read the newspaper whilst driving. If 300 drivers are selected at random, find the probability that exactly 25 says the newspaper, read the newspaper while driving. So here our 66% represents our probability of success. Once you subtract 1 minus 1 from the 1, you subtract 0.06 from as 1, we are getting 0.94. And here our n is 300. Our n is what? 300. And we have been asked to find probability that our x is equal to 25. Right? You can see that our n is very high, it's large, for us to use the normal distribution to calculate. The binomial distribution to calculate. Right? So here we have to test. If when we test by using n times p and the n times q, if it is greater than or equal to 5, then it is telling us that we can use the normal to approximate what we call the binomial. So when we come here, we have n times p, and then we know that our n here too is 300, and our p is what? 0.06. So here we are having 300 times 0.06, which is giving us what? 18. And then nq will also give us 300 times 0.94, which will give us 282. This is just telling us clearly that our n times p and then n times q, they are all greater than or equal to what? 5. So this means that we can use the normal approximation, the normal to approximate the binomial distribution. Right? So here we have to, if you are using the normal to approximate the binomial, we know that for us to be able to calculate for the probabilities, for us to be able to calculate for the probabilities of a normal distribution, we use what we call the standard normal distribution. And we know that the standard normal distribution here is given by our x, which is equal to, So which is giving us our x, which is equal to, So here, as I was saying, we are going to get z, which is our z score. Z is equal to x minus mu divided by sigma. So this is what we are getting for our standard. This is what we use to calculate for probabilities for the normal distribution. That's our z score, right? So here we have to calculate for our mean, and we have to calculate for what? Our standard deviation, right? So we are going to use the approach that we use to calculate for our mean and then standard deviation when we are treating the binomial distribution. So please, if you haven't watched the videos on binomial distribution, kindly go back and then watch the videos before you watch this one. So we know that our expectation, that's our mean, is equal to n times what? P, right? And then our sigma is equal to square root of n times p times what? Q. So this is what we have. So that is what we have done here. So we know our n to be, the mean to be n times p. So our n was 300, our p was 0.06. When you multiply, we are going to get 18. And then for the sigma, the square root of n times p times q, when you multiply everything and square root it, you are going to get 4.11, right? And we just learned from the continuity table is that when we have probability that our x is equal to a, is equal to probability that our a, you subtract 0.5 from it and then add 0.5 to our a. So that's what we have done here, right? So initially we are having 25, exactly 25, which will be probably that our x is equal to what? 25, right? So this is how you do the expansion. So here you are just going to subtract 0.5 from it. Of which when you subtract 0.5 from 25, you are getting 24.5. And then when you add 0.5 to 25, you are going to get 25.5. So this is how things are going to be done here. So since we are using the normal distribution to approximate binomial, we know that we are going to use this formula. We are going to use the Z formula. So here we have our x to be 24.5. And here we have our x to be what? 25.5. So our mean was given as 18 and our standard deviation was given as 4.11. So here we have to find our Z1 and then Z2. After that, you go straight to the table, the normal distribution table, and then just calculate for our Z, right? and then once you get the z, we are just going to subtract the probability for the 25.5 from the probability from the 24.5, right? So our z1 here will be the x, that's 24.5 minus the mean, well, that is what we have here, x minus mean divided by sigma. So minus 18 divided by 4.11, right? Sorry, 4.11. So once you do this one, I'm going to get 1.58. And then for the z2, we are going to take the last one, that's the 25, to be x. 25.5 minus 18 divided by 4.11. We are getting our answer to 1.82. So right now, we are having our probability, we are having this one to be in this form, right? So you have to go to the normal distribution table and then get the probability for 1.82 and then 1.58. So here to be, this one will be same as phi of 1.82 minus phi of 1.58. So this is what you are going to get. So once you go to, I have teach you how you can calculate your probabilities from a normal distribution table. So please, if you haven't watched the video on that, kindly go and watch it, right? So that everything will be helpful for you. So phi of 1.82 here is going to give us this probability, 0.9656, and phi of 1.82 is giving us the probability. Phi of 1.58 is also giving us what, this probability, right? So we are just going to subtract this one from that one to get 0.0227. So this one is going to be our probability for the question above. So let's go to the next question. So for the next question, we are saying that of the members of a bowling league, 10% are randoms. If 200 bowling league members are selected at random, find the probability that 10 or more will be rendered. So at the end of the day, we have our p given, right? We have our p to be what? 10%, that's 0.10. Then we have our n to be what? 200. And we are asked to find the probability that our x is equal to, our x is greater than or equal to 10. Our x is greater than or equal to 10. So we have this one. So let's say, because our n is very huge, even if you want to point it into your calculator, you are going to get, one way or the other, are going to get error. N is very huge. So let's test if you can use the normal to do this question. So here, our NP is equal to 200 times 0.10, which will give us 20. And our NQ will be 200 times 0.90, which will give us 180. So this is what we will be having here, right? So this is just telling us that we can use normal to approximate this binomial. So you calculate for our mean to be this, and then calculate for our variance, our standard deviation to be that. And then we have just been asked that our probability that our x is greater than or equal to 10, or let me use the a one so that you remember, is equal to a is equal, this one is equal to probability that our x is equal to our x is greater than a minus 0.5. So that's what he has done here. We subtract 0.5 from this one, and then he's getting 9.5. So for this 9.5, this one will be our x. So our z will be 9.5 minus 20 divided by 4.24. Right? This will be on the negative z table. So you just go locate the first two digits on the row and the last digit at the column. Where they emerge will be the probability. Right? But note, this one was greater than, this one was greater than probability that our z is greater than or equal to negative 2.48. You have to change it to 1 minus probability that our z is less than, less than or equal to negative 2.48, right? So once you check the probabilities from the normal table, we are getting 0.0066. Right? Just subtract it from 1 and we are going to get 0.9934. So please, if you haven't watched the video on how to calculate the z-score on the standard normal distribution table, kindly make sure you visit the video on standard normal distribution to learn that one. That will be very, very helpful for you. Okay, so let's go to our last question. I'll give you some assignments. When you are done, kindly present it at the comment section for me. So our last question is, if baseball players betting average is 0.320, that's 32%, find the probability that the players will get at most 26 hits in 100 times at bet. So we have this question. So our P is given as 0.32, our Q is given as 0.68, and our N is given as 100 from the question, right? And we have been asked to at most means our X is less than or equal to 26, right? So here our N, so you have to just take, because our N is very huge, right? So here we have an MP to be equal to 100 times 0.32, which is 32, and here to be 100 times that, which is 68. So this is just telling us clearly that normal can use to approximate binomial. You have to just calculate our mean and then standard deviation, and then use our, since it is at most and then less than or equal to, you are going to add 0.5 to it to be 26.5. So we are having 26.5 minus 32 divided by 4.66, which will give us negative 1.18. So when you go to the normal distribution table, you're just going to read this one from it, and you are going to get 0.1190. So this is that for the normal approximation to binomial, right? So this is the assignment I want to give you. There are two assignments, assignment 1 and assignment 2. Please, if you haven't watched the video on introduction to normal distribution, kindly watch it and then do the assignment. Share it at the comment section below for me to check. So thank you for visiting to my channel, Statistics and Mathematics YouTube channel. If you haven't subscribed, kindly subscribe, like and comment so that this video, and share so that this video will go viral for people to also get in touch. Rate the video. Bye. Have a great day.